Okay, so it says we're gonna start with the red paper clip.
Tilt this up.
And you should have 3 slips of paper in that one. So there are 2 steps, and then there's one that says calculate the overall enthalpy of change. Okay, so we're gonna start with that one. That's gonna be on top. That is the goal we are trying to get to. Okay, and it should have the same reaction that's in the middle of that section, N2 plus 2H2, arrow, N2H4. Okay, now on the other slips, if you look at one side and then flip it over, you should notice a couple of changes. So what is the change in the number? How does the number change when you flip it over? Yeah, it's either negative or positive, but it's the same number, right? Okay, now if we look at the equation, so this one here has NH3, which is what chemical? Ammonia. That chemical is a product, but if I flip it over, it's a reactant. Okay, so in flipping over the paper, you are changing the direction of the reaction. Okay, so what we want to do is we want to be able to put these 2 together to form this one. Okay, so we are going to look at what are the reactants of our goal, and that's nitrogen and hydrogen. Okay, so if I look at this piece of paper, I have nitrogen and hydrogen as products. So I'm going to flip it over. Now they are reactants. Okay. So since this is facing the right direction, I'm going to go ahead and write that on the first line on the piece of paper. Reactants. Okay. So since this is facing the right direction, I'm going to go ahead and write that on the first line on the piece of paper. Okay, and then I'm going to go back to the second one and say, okay, here I have N2H4 as a reactant, but I want it as a product. So I need to flip this around. Right? And so I'm going to copy that down here. Along with its energy. All right, now I want to make sure that when I add together the equations, I get the overall equation. So I can either look at the slips of paper or I can look at this, but since other classes have to use this, I don't want you to write on the slips of paper. All right, so I have one of these as a product and one of these as a product. I have one nitrogen and one nitrogen. These 2 cancel out. Oh, and I missed something, didn't I? What's H2? Yeah, there should be an H2 here. All right, and then here I have 2 hydrogens, and here I have 3, but one of them will cancel. Okay, so they look like they are good the way they are. But what I'm going to do is I'm going to write the equation down here by adding up all of the reactants and the products just to make sure. So I have 3H2 plus N2 plus 2NH3. That's all of the things before the arrows. And then after the arrows, I have 2NH3 plus N2H4 plus H2. And that's all the things after the arrows. And then I'm going to find the things I can cancel. These I have the same amount, so I can cross both of them off. But the hydrogen, it appears on both sides, but I have more on one side than the other. So this would be like if I had 3x on one side and 1x on the other. So I'm going to subtract 1 hydrogen from each side. So I'm just going to change this coefficient to 2. And now what's left over is 1 nitrogen, 2 hydrogens, an arrow, and then 2H4. So that means if I add these equations as they are, I get the reaction. So I should be able to add the energies as they are to get the energy. Okay, so I'm going to leave this math to you. I can, or you can grab a calculator if you want to. For the next one, you will either have a white paper clip or, because I was running out of colored paper clips, a silver paper clip. This one is a little bit tricky because all of the reactants and products show up in one of the equations. So you have to use the other 2 slips to cancel out the things that are not part of it, all the carbon stuff. So all of the carbon dioxide and carbon monoxide, you're going to have to flip around so it cancels out what's in the 3rd slip. Okay. Okay, so I think I have looked at most people's here. You want this piece of paper to have the iron by itself as a reactant and the iron 2 oxygen 3 as a product. And then because the CO and CO2 don't show up in the overall reaction, don't show up here, we need to cancel them. And the way you're going to do that is CO2 is a reactant in this equation. So I need CO2 to be a product here. CO, carbon monoxide, is a product here, so I need it to be a reactant here. Okay, so these are facing the right direction, and you can copy them down onto the paper, but then you have to figure out how to get the numbers right. The first one you want to look at is the one that has the chemicals from the reaction. So since this only has 2 irons, but our overall reaction has 4, this one has to be multiplied by 2. And then you'll figure out these other 2 based on this. Okay, so at this point, just having copied things down, I'm not ready to add up the numbers because these numbers don't match the overall equation. So what I'm going to do is I'm going to say I need there to be 4 of iron, and I only have 2. So I'm going to multiply this whole equation by 2, which means I need to multiply this number by 2. So that's going to give me 6 carbon dioxides, 4 irons, which is what I want, 2 iron oxides, which is what I want, and 6 carbon monoxides. So now I have 6 each of the carbon dioxide and the carbon monoxide. So I have to figure out what do I have to multiply these equations by so that I can get rid of the carbon monoxide and the carbon dioxide. All right, who wanted me to come check this?
Yeah.
So what do I have to multiply this second equation by in order for my carbon monoxides to cancel?
6.
6. And what about the last one?
6.
Also 6. So when I do that, I should end up with 6CO, oops, I'm mentioning 6, CO, and then 6C, and 6 oxygen, and then for my products, 6C, 3 oxygens, and 6 CO2. Okay, but I have to remember to multiply the energies as well. Okay. So as I go through here, 6 carbon dioxides cancel, 6 carbon monoxides cancel, 6 carbons cancel. What do I do with the oxygens? I have 6 on this side and I have 3 on this side.
Take 3 off the reactant side.
Yeah, take 3 off of both sides. So if I take 3 off of this side, they disappear. And if I take 3 off of this side, I end up with 3 oxygens. So then I have 4 iron, which matches this, 3 oxygen, which matches this. Everything else is canceled here except for the 2 iron oxides. So I should be able to add these up. So I'm gonna leave that multiplication in addition to you. Now, for some reason, but on the back, you're gonna go and look at this paper. There's just one per desk. So this is the same kind of table we were looking at the other one. And we're gonna write down what are the enthalpies of formation for each of these things. So iron should be 0, oxygen should be 0. And then you're gonna compare the enthalpy of formation for iron, iron 3 oxide to what you came up with on the other side. Now you're gonna find it's different. You know why it's different. And then once you've done that, then you can go on to the next. All right, so when you do this on this side, you're gonna find that for iron, instead of negative 1600, it's closer to negative 800. Why is it different?
Because from the it's 2 SE2.
Exactly. So here we're making 2 irons. And on this side, it's the enthalpy of formation of 1 iron. Okay? So if we double 800, we get about 1600.
We get about.
So it should be the same number in both cases, or very close to. So one thing that can be confusing is that when you are trying to match the equation, sometimes we want to match things on the same side and sometimes we want to cancel them out. So for our goal equation, the one that is right next to where it says calculate this, we want the other equations to match it on which side it is. For the one that is, for anything that is not part of this, so I see water is not part of this, then I want the water to cancel out down below. So this is not facing the right way. This is just my slips as I pull them out.
Oh, what is this?